Hello everyone, I'm Miss H, and today we're going to be looking at classifying matter. Now, before we can actually classify matter, we need to know what matter is. Matter is anything that is made of atoms, has mass, and takes up space. For the purposes of an introductory class, everything is either going to be considered matter or energy. So anything that we know of that exists is going to either be matter or energy. So anything that kind of is all that other stuff that's not energy out there, for our introductory class, we're going to think of that as matter. When it comes to actually separating matter, classifying it into its different parts, we have to ask ourselves a few questions. The first question we ask ourselves is, can it be physically separated? So a physical separation is a way of separating materials or taking the parts of it apart that does not require a chemical change. So things like using a filter or having substances that have different melting or boiling points. Even something like physically taking one part and pulling it apart from another. If we can physically separate it, then we call it a mixture. Mixtures are types of matter that have the ability to be physically separated. So they can be separated without having a chemical change occur. They can be separated by things like filtration or differences in melting and boiling point, differences in appearance, those sorts of things. So then the next question we ask ourselves if we have a mixture is it the same throughout? If I take a sample from the left, the right, and the center, are they all going to be the same or are they going to be different? If I take a sample from the top and the bottom, are they going to be the same or are they going to be different? If they are different, if they're not the same at the top and bottom or left, right, and center, then we call that a heterogeneous mixture. Heterogeneous mixtures usually also look different. Some examples that you might think of would be things like trail mix or granite countertops. You can see the different pieces that make it up. If it is the same all the way through, every sample I take from it is the same, it looks the same all the way throughout, then we call that a homogeneous mixture. Some examples of homogeneous mixture would be things like steel or air, things that when you look at it, it looks the same all the way through, and if I were to try to take samples of it from various places, they should be the same or very similar. Now going back up to our original, can it be physically separated? If the answer is no, it is a pure substance. This means that I can't separate it by filtration or changes in or differences in melting and boiling point or physically pulling the pieces apart. So then I'll ask myself, can it be chemically separated? So can I have a chemical reaction that will separate the different components? If the answer is no, it's an element. Elements are located on the periodic table of elements. There are 118 of them. If it is not one of those 118 elements, then it is not an element. If it can be chemically separated, then it's a compound. Compounds are combinations of two or more different elements in fixed ratios. Some compounds that you're very familiar with would be salt, sugar, and water. So again, just to put this in words to help you see what we just talked about and make sure that you can get all of this down, pure substances cannot be separated by physical means. This is broken into two categories. The first are elements. These are the simplest form of matter that cannot be separated by chemical or physical means. So elements are not able to be broken down into anything simpler without looking at the nuclear components, things that are what are called subatomic particles. Once we get down to the atomic level, that means we for sure have an element. There's no going smaller. Compounds are chemical combinations of two or more different elements. They exist in fixed ratios. And again, some examples you might know of for compounds would be things like salt, sugar, and water. Again, elements are any of those 118 that are on the periodic table of elements that can be found very simply through Googling or have been provided for you by the teacher. Elements can also be further broken down into different categories. We're going to talk more about these in the next unit. But there are three basic types of elements. You have metals, nonmetals, and metalloids. Now it's important to remember that elements don't exist in kind of this black, white, or gray area. They kind of exist on a spectrum with the most metallic at one end and the least metallic at the other end that we call nonmetals. And those that have properties that are in the middle of the two are referred to as metalloids. Again, we'll talk more about these in the next unit. For now, just it's kind of enough to know that they exist and that the majority of elements are metals. Again, when we look at our mixtures, these are physical combinations of two or more different substances. Again, they are not held together chemically, they are only held together by a physical means. If it is a homogeneous mixture, it will be the same all the way through, meaning that every sample will have the same or very close to the same chemical composition or physical composition. Homogeneous mixtures include solutions. So a solution is something where one substance is dissolved in another and it cannot be separated by filtration. So examples here would be acids, bases, and salt water. So if I pass salt water through a filter, all of it goes through, it doesn't get separated, but I can separate the salt from the water by boiling the water off, and then my salt comes back out of that or allowing it to evaporate off. And so again, boiling and evaporation are both examples of physical changes that don't require any chemical change to occur to separate that salt and that water. Solutions have two components. The solute is what gets dissolved. So if we're talking about salt water, the salt would be the solute. And the solvent is what does the dissolving, what has the other substance dissolve in it. In this case, in the salt water, it would be the water. Water is actually considered to be the universal solvent because it will dissolve the majority of substances, both ionic compounds and polar molecules rather. The only thing it can't dissolve are nonpolar molecules. Again, we'll talk more about these later. An alloy is a type of solution. It is a solid solution that contains metals, and the alloy can be separated by the different melting points of the different metals. Heterogeneous mixtures are ones that are different throughout, so a sample from one part will be different than a sample from another part, and the physical and chemical properties may also be different. A suspension is one type of heterogeneous mixture. It is where one substance is sort of floating within another one, and it can be separated by filtration. So if we look at something like orange juice, if you pour orange juice, especially if it has a lot of pulp in it, through a filter, the pulp will sit on top while the rest of the juice passes through. So that'd be an example of a suspension. Anything that says shake well is going to be an example of a suspension where one thing is kind of floating around in the other and it will settle down to the bottom when it hasn't been used. So that's why you have to shake it to resuspend it. The final type of mixture is what's called a colloid, and this is where one substance is dispersed throughout another. Usually it cannot be separated by filtration, but some types of colloids can be. Depending on the type of colloid that we're talking about, it may be considered to be homogeneous in the case of something like homogenized milk. So if you look at dairy milk at the grocery store, you'll see that it always says homogenized milk on it. And what that means is that it has been treated so that the different components of the milk don't separate. And that's why you don't have to shake it before you drink it or before you use it on your cereal. Other types are considered to be heterogeneous, like fog. So some parts of the fog are thick and some are easier to see through, and that's that heterogeneous nature where it has different types, different parts throughout there. So again, this is just a quick overview of how we classify matter. We'll talk more about parts of matter in other videos, and I hope that you found this helpful.